Hello everyone, this is part 1 of my review of my SMO Junior mock paper. I do not actually have a fixed number of questions that I want to discuss. On the contrary, I would like to just do a quick intro first, and I'll keep this video length to somewhere about 20 to 25 minutes. That's because my general take is that for the SMO, it's okay after about 25 minutes to just give yourself a quick breather to catch your breath, literally as well as mentally. So I do not want to make this video too long either, as well as the subsequent parts. So we'll see how many questions we get through. But the first thing to just do a quick outline of is what sort of targets you may have. Okay, so if you haven't already tried the junior mock paper, please look in the description below. Feel free to try it first before coming back to this and the subsequent review videos. The targets for the SMO as a whole are not fixed, both in terms of score as well as what you personally want to aim for. But of course, goal depends on round 1 plus round 2, so we'll talk about that another time. The round 2 cutoff is usually around 15. And then below that is silver, which is around 12 to 13. You have got bronze, which is usually around 9 to 11, and you have an honorable mention, which is somewhere about 7 to 9. Now this literally changes every time I write it. So some of you may look at my old videos and say, didn't you say something different? And the answer is yes, because in my mind I'm kind of just averaging what I know of the last 2 or 3 years, and it does move. It's a moving average in a way. So don't worry too much about the exact score, except to know that for this paper, I think it is also a relatively tricky paper. So I wouldn't expect it to be, in a hypothetical situation, that the cutoffs be much higher than the lower ends of the spectrum. Now what this means is that, for example, if your aim is that I'm new to the SMO, this is the first time, I'm happy with, let's say, a bronze would be great. Now that you could get relatively safely with something about 10 questions, and therefore the amount of time you have is quite plentiful. Therefore, whatever pace we go in these videos is just for me to talk a bit about the questions as well as talk a bit about the SMO as a whole, but the solutions themselves are pretty short. You have quite a lot of time to find them, so in your experience during the SMO, you'll spend more time thinking about what to do than actually doing it. Okay, so this is just a quick word on how the SMO would be, especially since this is the SMO Junior video and many of you are taking the SMO Junior for the first time. Alright, so let's go straight to the first question. Exactly one of the following is a prime number. Which one is it? Multiple choice questions in the SMO allow you to have a little bit of chances to do guesswork, elimination, intuition. It's not guessing in terms of random guessing, but it's multiple choice for a reason. So for this one, prime numbers are very hard to verify to be prime, but it is very easy to verify that something is not prime. So just do it by elimination. Options B and D are even, they're not prime. Option A is ending in 5, that is certainly not prime. And for C and E, the next easiest divisibility test to apply is 3. And the test is of course adding up the digits and seeing whether that total is divisible by 3. This is 22. And this is 30, so this is divisible by 3. This is not divisible by 3, and therefore you can eliminate option E. 4, 5, 6, 7 should be prime by elimination. Now, like many problems, actually a question setter like myself will be doing it differently from you. So I would just need to check that 4, 5, 6, 7 is really prime in order for the question to be accurate. You do not need to check that, as long as you know that the rest of them are not prime. That's good enough for you. Second question. 150 students sat for a mock SMO Junior paper. All scores are between 0 and 25 inclusive, like an actual SMO Junior. Their total score is 2024. What is the maximum number of students who could have obtained the same score? If you have immediate intuition for a question like this, good for you. If you do not have immediate intuition for a question like this, look at options and you see it goes to 148. Now obviously 150 would not work because 2024 is not a multiple of 50. But let's try and understand why 149 would not work. Now if 149 students obtain the same score, what I want to do is to just divide this by 149 and I would get 13, remainder 87. Right, for calculations like this, I'm just shortcutting it in my explanation, but obviously you would take more than 5 seconds to write it down, right? I said the question, so I know the values. Don't worry about calculating too fast. Anyway, this explains why it's not possible, because if there were 149 students who scored 13, the last guy can't possibly score 87. If you get 87 for the SMO Junior, it just means that the SMO system has messed up. So it is the same logic if I change this to 148. Can I get it? Well, if I divide by 148, I should still get 13. 13 times 148 is going to have the remainder go up by 13, so it goes up to 100. Now this still doesn't work because I would not be able to have the other two students collectively score 100 points. Same if I adjust it up. Certainly 3 students cannot get a total of 113. 4 students cannot get a total of 126. And 5 students cannot get a total of 139. But when you go to 144, what happens is that it's not 13 remainder 152, it overflows to 14 remainder 2. So 14, sorry, not remainder 2, remainder 8. 152 minus 144 is 8. But doesn't matter. Really, the idea is that the other 6 students obviously can get a total score of 8. It's not very impressive, but it is mathematically possible. So therefore, our answer is 8. Question 3. Now, I put question 3 here. Apart from the content of it, it is also a meta message that I'm trying to convey. Please do not assume that the multiple choice questions are the 5 easiest questions of a SMO paper. No one promised that. This is not like, let's say, PSLE, where the first 10 questions in your multiple choice are supposed to be 1-mark questions, for example, because they are easiest and they are multiple choice. Now, these ones are multiple choice, but everything's worth 1 mark. They may be easy, they may not be easy, and this is certainly not easy. Now, in terms of the question itself, what I want to say is that equations that you don't really have any clear understanding about, just try to rearrange them to be nicer and nicer until you can figure out what to do. So the first thing I'll do is add the 2 fractions. Common denominator. And then I will cross multiply. And I see xy is in 3 of the options there. But looking at this, I have no way of telling whether it is positive or negative, rational or irrational. Since I have no way of telling whether it is any of these, I shall continue trying to solve it, but how exactly do I continue to solve it? The idea comes from looking at x over y. You see, this is a quadratic equation where you have got y squared, x squared, and xy. Everything is power 2. X and y also have 2 things. But I can make it look like x over y by dividing by y squared. and this would give you a quadratic equation in terms of x over y. Now take note that this is a quadratic equation in terms of x over y that you cannot factorize, and that would already imply option E. Anytime when you cannot factorize a quadratic, it means that it doesn't have any rational roots. And since the question tells you x, y are real numbers, we do not need to worry about what if there's actually no real roots at all. It does exist because the question tells me so. So this is enough. For those of you who know the quadratic formula, you would be able to compute that the value of x over y would be -1 plus or minus square root 5 over 2, which certainly is irrational. It also tells you that depending on your choice of x and y, it is possible for this to be rational or irrational. It is possible for this to be positive or negative. Not an easy question. Problem number 4, if you're looking at the diagram, looks like a right-angled triangle. Is it a right-angled triangle? It turns out it doesn't matter. It could be, it could not, it may be, it may not be, but it doesn't help you at all. So whether it is or it isn't is largely irrelevant to the problem. Instead, what is more relevant, apart from the lengths that we have, so this is 13 and this is 5, apart from the lengths, we have got a pair of parallel lines. Now, during my classes, I often will tell my students about similar triangles always come from parallel lines in two patterns. Pattern number 1 is a so-called pyramid pattern. If you have got parallel lines like this, then the small triangle is going to be similar to the whole thing. Pattern number 2 is this so-called hourglass pattern, where the top half is going to be similar to the bottom half. Similar triangles mean same shape, different size, and same shape means same angles. So in this case, because of corresponding angles, and in the second case, because of alternate angles, we do know that they are similar. The use of similar triangles is that you can move ratios around, and that's what this question is all about. The first pattern of the pyramid appears in ADE and ABC. Now, if AE to AC is 5:13, then the 5:13 will also apply to, well, I guess I should say 5:8 for this one because it's a bit difficult to mark out, but for DE to BC, that is also 5:13. Now, they are not the lengths being 5 and 13, it's just in terms of ratio, and that's enough for me to use my second pattern. The second pattern, of course, being the aforementioned hourglass pattern. The hourglass pattern here means that the 5:13 carries to even more places, namely DF to FC and EF to FB. That's quite a lot. Now, with all of this being implemented, we have no more information we need to find. We can just go straight for the area of ACF. Start with ABC and first slice it into ADC. ADC is 5/13 of the triangle because the base is 5/13 of the whole triangle. So 5/13 of 39 is 15. That's ADC, and ACF is going to be 13/18 of what we have just gotten. Value, once you compute it, is 65/6. That's option C. Question 5. Now, in the SMO, one of the general trends that distinguishes it from the primary school Olympiads is simply quite a lot of algebra. Now, all the questions that use algebra will require the same few identities. There could be geometry questions, counting questions, number theory questions, but there will be problems like this that are particularly challenging your algebra fluency. I suspect that working with the cube roots is not going to be very enjoyable and also quite difficult to do accurately. I also suspect that some of you would try to guess x and y and you are not going to find nice values of x and y. And therefore, we should do something rather different. But if you want to do all of the algebraic manipulations with cube roots, why not get rid of them first? Instead of cubing this, substitute it away. Now, no one ever has forbidden you from changing the names of your variables as long as you do it consistently. So a minus b is 2, a cubed minus b cubed is 20, and x squared is the square of a cubed, so it's a to the 6 plus b to the 6 is what we want to find. I can almost get this by squaring. If I square this, I have a to the 6 and b to the 6, as well as a junk term in between that tells me I need to find ab. So to find ab, I use the first two equations. Firstly, by factorizing, using the difference of cubes identity to conclude that a squared plus ab plus b squared equals to 20 over 2, which is 10. At the same time, when I square a minus b, a squared minus 2ab plus b squared is equal to 4. So I subtract the two equations, 3ab equals to 6, ab equals to 2, and therefore this is equal to 460. Now with that, we're able to proceed on to the short answer questions. And the short answer questions do not necessarily progress on in difficulty from the multiple choice. Right? Usually, not always, but usually question 6 kind of resets to a quote-unquote easy question, which I may have failed in slightly because based on the statistics I got from the submitted answer so far, a lot of you found question 6 to be difficult. So that allows me to bring in one of the adages that I always feel is important for the SMO. Now, we always talk about how the SMO is a difficult contest, which is true because a contest where 50% is a very good score is certainly a difficult one. But that doesn't mean you should go into the SMO thinking about each question in isolation being very difficult. So you have heard of people running a marathon and just breaking it down into, let's say, 1 minute intervals or 100-meter intervals or 1 kilometer intervals, like something that they consider manageable. And they tell themselves, oh, 100 meters is easy, I just need to run that a lot of times. I'm not sure whether running 400 and 200 meters is going to be easy, but you don't think that. You think of 100 meters at a time. So likewise, when you see a question, ask yourself, why is this question easy? Assuming you are stuck. Ask yourself, why is it easy? In this case, it is easy because 26 is just really big. It's a big digit sum. Because it's such a big digit sum, it's quite unlikely. And because it's quite unlikely, it is possible to list. Listing is not wrong. It's only bad if there is a lot to list. You see, if there are 3 digits, 2 digits you can forget about. 3 digits just means that your maximum is 9 plus 9 plus 9 is 27. This is 26. So you get to chop off 1. And it would be 998, 989, 899. For 4 digits, the first digit has to be 1. It can't be 2 because if the first digit is 2, second digit is 0, that's not enough. So you have got, it starts with a 1, and now these have to sum to 25, which is still very close to 27, and so you have to take away 2 from the 999. That would either be 7, 9, and 9, or 8, 8, and 9. That's all. Answer is there are 9 of them. Alright, let's do one more question and we will conclude this section of the video. So we have got number 7, which looks pretty scary, and I'll just give a quick suggestion as to what you can do. Now the first thing is that the substitute directly and then calculate x to the power of 4 is not explicitly wrong. If you know the binomial theorem, it can work. However, it is a little bit scary. Now, I noticed that 256 is actually going to be 4 to the power of 4. So this is x to the 4 plus 4 over x to the power of 4. Now, what I'm curious about is, what is 4 over x? That might be easier to compute, and so I am going to go for that. The way we simplify this is using the conjugate. The conjugate of a combination of square roots is that you flip the sign of one of them, and this works well because of your difference of squares identity. At the bottom, you'll be left with 24 minus 20, which is 4, which cancels off. That's a very sweet sound. Every time when we say it cancels off, we know we're on the right track, because it means that x is this, 4 over x is this, and so I can start from x plus 4 over x. Is 2 square root 24, which is 4 root 6. And then I shall square this. You get x squared plus 8 plus 16 over x squared is equal to 96. Move this over and then square again. Now this is how you would avoid the binomial theorem. It is, of course, not wrong to use the binomial theorem. It's only contingent on whether you know what it says. Okay, and so your answer is 7712. The SMO answers are up to 5-digit whole numbers for the short answer section, so 0 to 99999, as I indicated in the answer form. So this is about the limit on the size of computations which you will need to do on your own. Just remember that there's no calculators, and so if you tend to make a bit more careless mistakes while computing, just do it twice to make sure that you don't mess up. Alright, and this is where I'll conclude the first part of the video. Thanks for watching, and see you soon for the second part of our review of this paper.